Welcome to a lesson with Dr. Powell. Let's take a look at an example of matrix multiplication by blocks. Now, the important thing to remember when we're trying to figure out how to partition our matrices into blocks so this actually works is that we just need one thing matching. That is how we've partitioned our columns over here and how we've partitioned our rows over here. So the partition I have over here needs to match the one I have over here. So right here, I have one column, then two columns, then one column. Here I have one row, then two rows, then one row. So it looks something like this in both cases. And so for rows, I would want something like this. Now, equally, I could have done it this way. I could have gone like this. If I did this with the columns, then with the rows, I better go like this. Of course, the number of columns here needs to match the number of rows, and so that's a given, but we also need the partitioning to match, and then we'd be okay with that. Okay, so anything else that we do with the partitioning is okay running the other directions. So we could for instance, so we see how we have lines going the other way, so that dividing the rows over here, we can divide the rows over here any way we want. We can divide the columns over here any way we want. Dividing up the rows over here actually corresponds to dividing up what we see in the final result of the matrix multiplication over here. See, we have 1, 2, 3, and we have 3 different places over here. Now, dividing up the columns over here, actually, that's what corresponds to dividing up kind of what we see in the result over here. Okay, so the other guys just have to do with dividing up what we see. And but as we run columns to rows over here, that's where the addition comes into play. Notice how we have like these guys right here. So this A is referring to this A, that B is referring to that B, C to that C, where I've kind of labeled these guys right here as A, B, and C. And notice how quite literally I'm just taking A times this D, B times this F, C times this H, and I'm getting that adding. So this pairing comes from matching the column partition to the row partition. That's the pairing where I add. And then the other guys, so the rows over here, these lines and these lines are just the lines that I see over here to kind of divide up where I'm looking at my what I see when I actually do the calculation and where I put it in the result. Okay, so with that, let's talk about what to do next after we have a partition that we know works, where we just have columns partitioning matching a row partitioning over here. Well, then we just label these guys. Like here, I've labeled them, the different parts over here. And over here, I've labeled them. And then you just matrix multiply these, pretending that these guys are elements. But one thing you have to keep in mind is that when you multiply here, order is very important. See how this would come before something over here. So you have to do like A times, like here, A times D. And then here you have B times F, and then you have C times H. Now, in this matrix multiplication, I've used a row interpretation of how to multiply these two matrices together. Basically, what I've done is I've taken A times the first row, B times the second row, and C times the third row. That's what you're seeing right here. See, A times that row is AD, AE with the A coming first because it comes from over here, and then the B to BF, BG, C to CH and CI. So I take these and add up the results, and that's what goes on the top of the result right here. Now, similarly, we get the middle section. The middle section comes from doing J times the first row, K times the second row, L times the last row right there, and adding up those results. And then for this guy, M times the first row, N times the second row, P times the third row, and then adding those results right there. So really, any technique that you have for matrix multiplication is good over here, as long as you just remember like this multiplies before that. And yeah, and you blocked it in a nice way over here where that respects the column to row partition being the same. Okay, so let's kind of actually run the calculations here in particular. So running through the calculations, this right here corresponds to the top, okay? So we're looking at this, and so we're looking at this right here, and we're taking like 1, and we're multiplying it to, and see how this is divided like this, right? So we're concentrating on one part at a time. So we're doing like this part to this part. So 1 times 1, then we're doing 0, 1 as a matrix times this column matrix 1, 1, and we can see that over here. So we see, okay, so AD is 1 times 1 right there. Then we have 0, 1 times 1, 1. And then we have -1 times 1. So -1 times 1 right there. Okay. And then we add those. Okay, so we add those parts together, and that actually gives us, so adding these together actually gives us that 1 right there. Then this part over here, where does that come from? That comes from when we're doing A times this second part on the other side of the line. So 1 times the matrix 1, 1 is right here, and that comes out to be that. And then we have 0, 1 times this matrix right here. So we'll see that. So 0, 1 times this matrix. Now, using a row interpretation, this simply just means to pick out that row right there, and that's what you see right there. And then over here, the last guy, -1, and the 0, 1 multiply together to give you 0, -1. You add the results, and you end up getting 1, 2, 0. So in the final result, this part right here is going to be 1, 2, 0. Okay, now we look at the next part. All right. So we have J, K, and L going on, coming from, sorry, J, K, and L, right? So basically, we repeat the same idea. This going to here, and this going to here. It's done the same way, and you end up getting, in the end, but just kind of looking at the different pieces as we go, 3, 2, 2. Okay, so this part would be a 3, 2, 2. Now let's look at this guy. Okay, so this times that row, that times that one, that times that one. So notice you have 0, 1 times that, and this times, so then you have this times that, and then this times that and that. The sizes respect each other perfectly just because we partition the columns and the rows to match. So we can really do those matrix multiplications. So here's just an illustration, but it's the same basic technique, and it actually ends up getting us the last 2 rows, since the results of these matrix multiplications are give out 2 rows. So in the end, we end up getting this matrix, and that is the product of the two. Thanks for watching.